Okay, so welcome back. We're going to multiply some other matrices here. So here we have the matrix A, 1, 2, 4, -1, and a new B. The previous video had a B that was a 2 by 1. It's another 2 by 2 matrix, 3, 8, 1, 2. So what we're going to do is, using the same ideas, we're going to multiply the two matrices together. And again, what I'm going to do is write it in the traditional way first, so you can see how it might be written in practice. But again, what I'm going to do is, to see how everything lines up, I'm going to put A somewhat down here, and I'm going to put B up here. That way we can see exactly what gets multiplied to get each entry. So if you think you have matrix multiplication down, I encourage you to pause this video and work it out on your own, and then come on back when you're ready. I'm just going to keep going here though. So in order to get the first entry here, we're going to multiply the first column by the first row. So that means that that's going to be 1 times 3 plus 2 times 1. So this 1 times this 3, and this 2 times this 1, and that looks like 5. To get this entry right here, we're going to multiply the 4 and the -1 to the 3 and the 1, and that looks like 11. To get this entry right here, it looks like we're going to multiply the 1 and the 2 by the 8 and the 2, and that looks like 12. And last but not least, we're going to multiply the 4 and the -1 by the 8 and the 2 and add, and that gives us 30. So hopefully you got that AB is equal to 5, 12, 11, 30. And yet at this point, I do encourage you to check out the video on multiplying matrices on your graphing calculator. If you put A and B in there and then multiply, find the matrix product AB, you should get the same thing. So just to illustrate what's happening here though, what if we wanted to find matrix BA? Now we saw before that AB was defined, but BA doesn't. So that kind of tells us that we shouldn't expect to get the same answer. In other words, matrix multiplication is not commutative. So I'm just going to write this out and see what we get. So again, there's a traditional way, and that means I'm going to put this matrix first. And then there's my answer. So something I skipped over before, so this is a 2 by 2, and this is a 2 by 2. So these twos tell me, yes, I can go ahead. And the outer twos tell me the dimension of the answer. So yes, it's going to be a 2 by 2. So here again, if you feel comfortable, pause the video and work this out on your own. I'm going to keep going here. So pause now if you don't want me to reveal the answer to you. So for this answer right here, so we're going to multiply the 3 and the 8 by the 1 and the 4. And that looks like 35. And right away you can tell we got a different upper row 1 column 1 entry. We got 35 instead of 5, so that tells us that the matrices are not the same. Okay, so if I want to find this entry here, it looks like I'm multiplying 1 and 2 by 1 and 4, and that looks like 9. And if I want to find this entry here, I'm multiplying 3 and 8 by 2 and -1, and that's -2. And to get this final entry here, I'm multiplying 1 and 2 by 2 and -1. Oh, look at that, we got 0. So that tells me that BA is equal to 35, 9, -2, 0. Okay, now something else we can do, we're probably not going to do it too much in this course, but it is possible to find powers of matrices, so I just want to talk about that. So a squared is just a times a. So I wish there was a nice fancy formula I could give you for multiplying, or for finding a squared. But, a times a, the best I can offer is just multiply the matrices together just the way we're used to it. I mean, hey, maybe a shortcut does come out of it. You never know. So again, I'm going to arrange it the same way if we're comfortable with that, because it seems to be nice that way. So one more time, if you want to pause the video, if you feel comfortable, go for it. I'm going to keep going here. So I'm just going to speed through this. So to find this entry here, the upper left-hand entry, I'm multiplying 1 and 1, followed by 2 and 4. So that looks like 9. So I'm actually going to get rid of this box. Okay, and then to find this entry here, so let's see. We're multiplying 1 and 2 and negative 1, so that looks like 0. And then to find the lower left-hand entry, we have 4 times 1 and negative 1 times 4, so it looks like 0. This is an interesting answer. So then if I look at the lower right-hand entry, we got 4 times 2 and negative 1 times negative 1. That looks like 9 as well. So very interesting result here. So this is a squared. And naturally, you can get a squared by multiplying either direction. Well, I guess there really is no either direction there. But so there we have it. So if your instinct was to square each entry, that doesn't work for squaring matrices, unfortunately. This gets really interesting when the dimensions get bigger, so we'll take a look at that in another example. But here we see how AB is not the same as BA, and A squared might not be what you think. So thanks for watching, and come back for more.